I don't think that there are barriers now. What the only barrier is time, because you're going to have people building these agents. As more and more of these agents are built out, as more and more of this spatial programming and this universal domain graph of the world, this digital twinning of everything with context baked in, as all of that is evolving and these agents are being built out and these agents are learning and growing in their knowledge and learning from each other, then, you know, it's just going to continue to evolve, you know? So really, to me, it's just time. But I don't think it's as much time as people might think, because the really cool thing is we've had all of these emerging technologies that have been growing siloed, right? But they've all been growing. And like we're at the point where, you know, there's apps on your phone where you can scan a room and get a 3D model from it, right? Like there's all of these capabilities that the beautiful thing about the programming language of the spatial web protocol, this HSML, hyperspace modeling language, is it not only becomes a language that these AI can communicate across, but it also becomes the common language for all emerging technologies to be able to become interoperable. So, and I'll give you an example of what that looks like. NASA JPL, right? They're one of the beta partners for Versus, and you know they're using this technology for their Artemis project, and you know they may have one team, you know, located somewhere like, say, you know, here in the United States, and they're building the rover, and maybe they're using NVIDIA Omniverse to build it, right? And then there's another team over in Europe, and maybe they're using Unity to build some other aspect of this. They can all come together in this simulated digital twin environment, and it does not matter what technology they have built with. HSML bridges it all. And that's going to enable a level of collaboration that we've never seen before. It's never been possible to have that level of collaboration between teams, regardless of what technology each one is using or prefers or whatever. This digital twin environment with HSML bridging it all, it just creates this level of interoperability that brings it all together. So when you're talking about IoT and distributed ledger technologies and AR and VR and, you know, AI is this powered intelligence that is, you know, drawing all of these connections between it all. It's pretty, it's kind of mind blowing. That's why I feel like we're about to enter this phase of innovation like we've never seen before. You know, the level of innovation that this is going to spark is going to be so fun to watch it unfold. And that's why I say all of this is an open source dream, because, you know, open source developers, they want to be able to have the tools and then just build with them. And, you know, to be able to have access to all emerging technologies and what you can do with them all together, and have them powered by these kinds of agents that are self-organizing, adaptable, you know, can learn, plan, and act in real time with live data.
Do you think that it makes sense to build agents that can browse the web for you? It looks like it's the direction that everyone is taking now.
I think
Uh,
that's the direction everybody's taken now, because that's what they've got. You know, we're in the World Wide Web still. I think that it's going to look totally different once we are in this, you know, once our internet is, you know, enabled with this, you know, digital representation of every physical thing, and it's all powered by AI. You know, the way we search, for a lack of a better word, because that's not really what it's going to be for this next era. It's going to be kind of a knowing, right? And these AIs are going to be the ones that
about our current financial system. Hey everyone, welcome to another episode of NEWFORUM, a research network dedicated to open learning in the arts and sciences, pioneering a new culture for internet design. Today, I'm thrilled to be joined by Sofyan, a visionary systems thinker and the driving force behind New Foundation, New Coin, NEWFORUM, and numerous AI breakthroughs over the past decades. I'm also super excited to welcome Denise Holt, an expert in active inference AI, spatial computing, and the future of AI agents. She's the founder and CEO of AI X Global Media, host of Spatial Web AI Podcast, and a voting member of the IEE Spatial Web Protocol. She's a leader in active inference AI and spatial technologies. She's shaping how AI integrates with our digital and physical worlds. Welcome, Denise. Super excited to have you on our show.
Hi, Salimi. Thank you so much for having me. Hi, Sofiane. It's nice to see you again.
Okay, super excited to be chatting with both of you, Sofyan and Denise. I admire what you're both doing, building, and all your impact. So my very first question for both of you, I'd love to hear both of your broader thesis on where the world is headed in light of AI's rapid evolution. There's just so much happening. So what should we expect in 2020, 2015? What am I saying? Oh my God. What should we expect in 2025?
We're having a time warp here. Sophia, why don't you go ahead and go first?
Okay, how many days do you have? Okay. Yeah, so definitely I think we are moving in a much more vertical phase of the exponential curve in like information processing, information communication, knowledge. Basically, we started about 500 years ago this curve from the first books to getting to the first computer. It took about 450 years or something, and then 50 years to go from the first computers to the smartphone that shoots the most optimized video to your eyeballs all over the world. And yeah, I think we are moving into a phase that's going to accelerate. And I think it comes with a lot of challenges and opportunities that are completely new. I believe the current infrastructures that we have are no longer fit to embrace those challenges and those opportunities. We have built most of our social infrastructure around things like governments, capitalism, like all those systems that were working for industrialism, for the phase of like dealing with challenges around how do we produce faster, how do we invest, how do we produce more, how do we kind of create the state as a way to kind of unite people and set some standards, some ethical standards between the machine owners and the workers and so on. Like all those challenges now are becoming obsolete. The problem won't be exploitation of humans. It will be more, oh, we don't need humans anymore, things like that. So we have to come together with a new conversation, a new form of, and now I'm obviously preaching for those technologies that we are going to talk about today. But really this idea that we need new coordination mechanisms that both leverage intelligence and that allow us to orient that very fast accrual of intelligence.
Absolutely. Agreed. I know that you and I are on the same page with where everything is headed with all of this. So it's really fun to be here and talk with you about it today. And, as everything that I'm doing is in the space of education around this next era of computing and this, emergence into a decentralized internet, which will also bridge all of these emerging technologies that have been all rising together but siloed from each other. So everything is about to be able to bridge across the internet with this new protocol layer that takes us into this digital twinning of everything. And the decentralization that we're able to have within this new capability of the internet is going to distribute intelligence across the network and push the compute to the edge. And active inference AI is what's going to make that possible. So, these agents won't have to be tethered to a giant database to do all their compute. It truly is a decentralized, collective intelligence layer that's going to be distributed across the network. So that's really exciting to me.
Yeah, I think the bit about decentralization is probably the most important to me. We see a lot of conversations around things like Project Stargate and open close AI, not sure how to call it anymore. All those like, and the Colossus from Elon Musk and so on. And you hear the founder of Anthropic saying, we are going to have nations of skilled workers that's going to deliver so much GDP growth, and they will all be sitting on that data center. And that's when he lost me, like the word center. Like the whole thing, I completely agree. Really like the idea of moving to a world where most of the labor, most of the things that take so many hours of our life can be done by intelligent machines. But I really don't like the idea that, we should trust one company, one corporation, one data center to run that. And
No.
so there are a lot of efforts to decentralize AI. And I think a lot of them are kind of like cute and funny, but I'm very bullish on what you guys are doing with Active Inference. And I think decentralizing intelligence is not decentralizing machines only, it's not decentralizing data only, it's really decentralizing the flow of that cultivation of intelligence. And that's very difficult to even explain, conceive, and so on. And that's again another topic where we have so much to talk about.
Yeah. Well, and it's really interesting because what it's going to do is it's going to really bring this layer of distributed kind of equal opportunity in this space too, which is really exciting, um, by having, so, to me, I don't see that AI will evolve in any other way, right? I mean, we've heard all of the reports of like LLMs, they've kind of reached their limits in both scalability and not just scalability as far as, the energy crisis of scaling these, but also you can only get so much out of one brain, right? For knowledge to grow, it really depends on the diversity within the networked knowledge sources and brains that are operating and learning and deciding and acting within that space. And you're not going to get diversity from, a bunch of agents that are all processing under one centralized brain, for lack of a better term, because it's not a brain, but you know what I mean. With the neural network layers, and really it's just essentially a giant database where the AI has just been pre-trained on a bunch of static data, right? That's not going to produce what we need from agents that can adapt and self-organize in real time using live data and updating their understanding of the world in real time, their understanding of their environment from their perspective of whatever tasks they're charged with, whatever their goals are, right? They need to be able to adapt in real time. And the only way you're going to get that is by having this decentralized aspect to it, where they're able to actually work on a localized level, and then they're also able to, in the same way they can learn about their environment or whatever they're tasked with, they can share information and learn from each other as well. And then what you have is kind of this organism of intelligence that grows in intelligence, and that's how the intelligence of agents will grow. It's not going to grow from one agent or one giant machine.
Yeah, exactly. And I think that what's fascinating is how similar it looks to humanity as a collective organism. So if you look at, we have our own nervous system, but then we have also collective neural systems. Like we kind of we feel together, we experience together, we share knowledge, we build constructs, we do all those things as communities. And I think that friction between different perspectives, that ability to communicate, whether through language, but all the other layers that connect us from Prague, Bratislava, California, I don't remember the exact city, but we are from like all those parts of the world, and we are able to exchange bits at very high frequency. And I think that there is no other way to AI basically accruing intelligence. When you start to have this flow of new data, new things happening,
Yeah.
cannot afford to have something that needs to be trained or retrained and I'm actually curious, like, what's your take on all those latest developments in AI? So if you take like all those inference time adaptation, you have a big family of them. You have the one from Meta, test time training or something, another one, or thought preference optimization, and then you have test time training that achieved a very successful score at the ArcAGI. And then like obviously test time compute, R1 and all of that. Like, do
Yeah.
you see it as like a kind of attempt to get closer to active inference
No,
using
because
networks, or?
Denise,
here's
before you
why.
answer that, are you able to define what active inference is?
Active inference is a methodology for AI that is based on neuroscience. Dr. Carl Friston, he's the #1 neuroscientist in the world. This is his methodology. He's been working on it for more than, I don't know, 10 years, maybe close to 15 years now. And it's based on his own discovery of the free energy principle. And what this does, what the free energy principle is it basically describes how all biological systems learn and adapt for survival. And so it's long been thought to be an ideal methodology for AI, for autonomous intelligence, but it's also long been thought to be near impossible because the compute is really complicated, but also for these agents to actually be able to learn and plan and adapt in real time, they need a grounded understanding of the world. They need to have a real world model. And so Carl Friston, saw what a company Versus AI was doing with this expansion of the internet protocol into digital twin spaces and this layered spatial protocol across the internet that'll enable spatial computing and expand the nodes to include all things in all spaces and nested spaces as part of the internet rather than just websites, which is that whole centralized model. All the transactions take place under the web domain owned by the centralized authority. Well, this protocol is going to distribute the transactions taking place at every touch point between things. Context can be programmed into all the things in all the spaces and the nested spaces, to describe the entities themselves, their relationships to each other, bake in permissions, bake in, all kinds of security layers. This is a much more secured protocol across our network, but it enables true decentralization. Well, that's what's going to bring these active inference agents to life. And to your question, Sophiane, as far as, what we're seeing with inference with these, deep learning models, the biggest difference between active inference and deep learning is a computer engineering approach to AI. It's algorithms and neural nets, and it requires this pre-training within a gigantic database, that all the queries have to be processed through. Active inference is different. Active inference is this biological approach where if you think of how humans learn, we are constantly taking in sensory data even from the time of infancy. Like you're born and this is how you grow and learn, and this is how your knowledge grows and learns. You're taking in sensory data, you're establishing and then updating your understanding of the world around you. You know, for an infant, they know their mother first, right? And then the rest of the people in the room, and oh, what happens if this drops? And you know, if you look at babies, they're constantly putting things in their mouths. They're constantly trying to gather information and gather sensory input to discover what the world is about. And that is how we grow. And as we get to be adults, you know, then we're starting to learn about specialized knowledge in different areas, you know, and that's how knowledge grows. That's how these agents operate as well. Only the sensory input comes from IoT and cameras and other things that are giving real live data. And then this context layer within the network of the spatial web, you know, our internet, but the spatial aspect to it, all of that context gives them an understanding of the world, the real world in real time, because all of that evolves moment to moment. So then you have these agents who are actually able to use live data. They don't even need large data sets. They're using, and so they're growing in knowledge. So, you know, we're going to see them, you know, begin as kind of these rudimentary agents, but they will actually be able to grow and evolve and learn, and their knowledge will grow. Whereas that's just not what's happening with the deep learning. Deep learning, these, you know, these LLMs, these transformers, they're amazing tools, but they're limited. And the biggest thing that sets them apart from active inference is causal reasoning. So these active inference agents, they can actually understand the why behind you know, this feedback loop and this process of discovering the world and then, you know, making predictions about what may come next, and constantly updating that prediction cycle. And I'll tell you why that's important. And this is what separates agents versus, you know, just trained bots that can just, you know, do tasks, right? Which is really what we're calling agents in the LLM world, but they're just trained bots that can maybe automate some tasks that they can handle, right? But a real agent needs to have agency. It needs to actually be able to make decisions, and make decisions that make sense for the context involved in the task at hand or the question at hand. And, you know, I'll give you a good example, you know, just the simple statement of the door is open, right? If ask an agent to make a decision on what to do based on that statement, the outcome of what you want that agent to do, it really depends on why that door is opened. Is it open because there's somebody waiting to come in? Is it open because maybe the wind blew it open or someone forgot to close it? Or is it open because there's an intruder and it's a security alert? You know, all three of those situations require a very different response from an agent. So you need to have, if you're going to have agents you can trust, you need to have agents who can also understand the why behind a situation.
I would say, you know, if you think about, you know, imagine if the only experience you have, now I'm going to talk about space. So imagine if the only experience you have about the world is because you have like you never went out of, you never even moved. You have been exposed to tons of books and screens that describe how the world is about, you know, how the world works outside. So you would be able to like say that, for example, purple is a mix of red and blue, even though you have never seen those colors. You could memorize that because you have heard those words. So you have read so much that you would know a lot of things, and you would be able to approximate decisions or approximate like things just based on reading tons and tons of text. And so when you look at the AI that we have today, it's an AI that is mostly built upon internet data, and internet data is not the real world. Internet data is a reporting of the direct exposure to the real world, for example, like Google Maps or things like that, they kind of try to report like pretty
Yeah.
accurately what's in the real world, or the kind of perception, like the translation through human perception to say, oh, it's hot, it's cold, like this kind of stuff. But as an AI trained based on that, you only have an hologram of the world. You don't have the actual world.
Yeah.
And so having the ability to collect data directly from the real world allows you to take the internet to the next level. So, when we talk about the metaverse, we talk about creating virtual spaces and so on that are like, so expanding the size of the land into and trying to replicate the properties of the real world. Here we are talking about something different, which is um, a kind of connection between the digital and the physical, where now you
Yeah.
can start running different forms of intelligence that
Mm.
not only know how to approximate a test data set, which is what we do today. So I think the thing that all those AIs have in common, and what I find very interesting as putting my new coin hat, where we are trying to be agnostic in terms of the model architecture, is all the systems that move towards intelligence, they are trying to run feedback loops. So they are basically, there is an ideal state, there is a goal, which is to approximate a good response. So, we do it every day as humans. We try to give the best response. Like you ask me a question and I try to approximate what you expect from me to be a good response. But also Zoom is trying to like measure, okay, what's the bandwidth of that computer? What's the internet? How is it going? Blah, blah, blah. And it will try to adapt based on all that. So all those layers are basically trying to optimize based on what it tries to achieve as a goal. So Zoom is trying to achieve the best possible image with the constraints it has. We as our conversation and so on. So all those AIs have this in common, but active inference is an approach where the entropy minimization or trying to achieve the desired goal is much more autonomous because the goal is not just a prompt or just a one step. It can be an entire, and actually I'm curious, like, what's your take on the concept of intent gap? So if we say like, you have the intent gap of my intent is just to like type a query to search the web. And then the next step is like, okay, now I click the website and now I'm browsing the website and now I have the information and now I act upon that information. Now you have 5, 6, 7 steps. So now we are working in that range of like creating agents that can actually do like the next 6, 7 steps. But then you could say, okay, let's go for the wildest intent gap, which is I want to be happy. And now you have an AI that's going to figure out like how to make you happy. So that's like kind of the extreme version. What do you think is like both philosophically and technically feasible in terms of like intent gap that we can expect from AI systems?
Yeah. So are you familiar with the work that Carl's team has been doing with renormalizing generative models?
Not yet.
Okay, so this is really fascinating because it's based on active inference, right? But these RGMs, they're one unified model that can do everything that requires these separate models for like in the deep learning sphere, right? Whether it's image classification, video generation, sound, gameplay, they can reason, plan, and act, and it's scale free. So these agents can gain the understanding of something or a complex system on a local level, but also a global level, and monitor it all, right? They understand all scales of it. And what's really interesting is that they use Markov decision processes, but they use them with paths as latent variables. So they're able to understand this scale-free picture of everything, but also understand, path states of of everything leading up to the current state. Whereas like with deep learning, the Markov decision processes are just the current state, right? So it's able to take into account all these past states leading up to that moment so that it can predict out, but predict out in this scale-free understanding as well of, at what point do you want to understand the predictability, and I think that's really, when you're talking about what you're talking about in being able to make these predictions as far as steps out of, anything from happiness or just how to do a process, this takes it to a whole different level.
So if we go back to your kind of analysis of like neural networks versus active inference, I'm quite curious about what you think about multi-step, like having, neural networks that start to, instead of trying to like spitting a whole like prediction, will start to introduce systemic interactions such as, for example, if you look at R1, how it has been unpacked in their paper and so on. So you have like different length of feedback mechanism, you have parallel computations, you have all those things. Like it's much more, I would say, it kind of reminds me of active inference. Like what's your take on that? Like it looks like they are trying to achieve using like more smaller inferences.
They're doing like
Also,
expert models, right?
yeah, exactly. Like
That
so
what
you
you're
have the
referring
expert models, you have the supervised fine-tuning, you have the reinforcement learning, you have all those steps that kind of, and the distillation aspect also, like the ability to create smaller, faster models by first going big and then like smaller and then having like all those steps. It kind of starts to me to mimic or to probably deep fake what Carl Friston and the active inference community has been talking about for years.
Except that it can't do causal reasoning. So, because it still is a pre-trained system, it's not going to handle live data and it's not going to be able to generalize well outside of the training data that it's working with. Um, you know, I, so the way I look at something like a DeepSeek, um, it's solving some of the issues that are in the LLM world with the what we've been operating with like OpenAI and these other companies, right? Like it's solving it and it's making some things more efficient. It's making it's making it putting it open source. I mean, obviously that's a huge benefit to open source developers right now, for them to be able to work with it and do what, do really cool things. But there's a limit on it, right? These are tools, really awesome tools, but they'll only ever be tools and they'll never be trusted for mission critical operations. Now, it's interesting because, versus the model that they're building, their platform to build these agents, to model them, and you're modeling these in a decentralized environment. This is an open source dream. So when this hits the market, the public market, I think that open source developers are going to just run to it because everything that's showing right now with their benchmark tests and they just did I don't know. Towards the end of December, they did this mastermind challenge. Mastermind is like a code breaking game. And they did it, Genius against OpenAI. And I have the stats here, and it was really interesting because they did 100 games, right? And it took like, I don't know, between 3 to 5 seconds for Genius to solve each game. 100% accuracy across 100 games, right? It took almost 5 minutes per game. Or maybe a little over 5 minutes per game for OpenAI. So a few seconds versus 5 minutes for them to solve. And they only had a 71% accuracy. It was 29% failure rate. They just did the same challenge last week with DeepSeek. And it was really interesting because, you know, with Genius for all 100 games, it was 5 minutes and 18 seconds. OpenAI was 12 and a half hours. DeepSeek took 26 hours to finish 100 games. DeepSeek had a 45% success rate. So OpenAI had a 71% success rate, but it was less for DeepSeek. DeepSeek did it cheaper, right? And faster, like half as much fast than OpenAI, but they also had a lot higher failure rate. And out of all three systems, Genius was 140 times faster than OpenAI and 5,000 times cheaper than OpenAI and 240 times faster than DeepSeek and 779 times cheaper than DeepSeek. So for as much as DeepSeek is an improvement on OpenAI and the other LLMs, active inference is wiping the floor with them. As far as energy, 90% smaller model size, and data set. With the Atari benchmarks, it was 90% less data, 96% faster training, 96% smaller model size. I mean, it's really a no-brainer. So right now, these DeepSeek models or any other alternatives that come in that make improvements in that space, they're all still LLMs. They're all still limited by the same things. They all have failure rates. They all are, they are all dealing with their same problems, right? But they might make them a little faster, more energy efficient, whatever. But then you have active inference over here. And once these agents start being built, and once this knowledge graph grows within the network of this spatial computing of our network, who's going to continue with these other tools that are requiring us to consider using nuclear power plants to power and the sustainability factor when these run on an like all of these challenges and benchmarks? Genius is running on a Mac M1 laptop. It's not, everything, all these other ones are still requiring the super powered GPUs. And, so I think that we'll have this transition period while this is growing out in the active inference stage, right? But there will come a point where, it just makes no sense to continue down this unsustainable road. And these agents will acquire all of that data knowledge that is within these giant databases. They'll absorb it all as they're learning and growing and operating throughout the network. It's just instead of that knowledge having to be in a database, it will be distributed through our network in the same way that all the knowledge of the world is distributed through websites and, everything else.
Yeah, it reminds me that quote from Carl Friston where he said it was in the peak of the hype around the Transformers back in 23, and he said it in very kind way that if you are building a system that requires more and more parameters and more compute and more energy, you are not creating intelligence, you are actually doing the opposite. You are kind of like running away from intelligence, because intelligence is this ability to, with fewer and fewer resources, you can achieve higher and higher output. And I think that's what is going to be so a lot of people have been debating around, yeah, is it the AI race, is it based on data? Who's going to get the most data? Or is it who's going to have the biggest compute? And I think it's neither. I think it comes down to the design of the software, the design of the data, the way it kind of abstracts how intelligence actually works. And that's a big mystery. We are still at the very beginning of understanding intelligence. Mm-hmm. But yeah, I think energy consumption and compute requirements is going to be, once everything is commodified and once everything becomes energy and once the whole economy becomes just energy, and the question is like, I'm using this solution, it's taking me 1, and this one is taking me 0.001 to achieve the same result. And yeah, I think that's where you have the biggest multipliers, but it's also very difficult. And I'm actually curious, what do you think about the bearish case? Like we have this like very, optimistic and confident and so on. Like, why is it hard, basically? Maybe not bearish, but like why is it difficult to achieve that kind of active inference-based AI?
Well, so because it does require this context layer. I mean, there's obviously there's complications with the math behind it. And in the past, it's been hard to scale, to scale that. But RGMs are solving that problem. All of the research that they've done this last year. I mean, they've launched a lot of or they've, published a lot of their research findings, and it's all solving those complicated issues to where now, I mean, really it's needing this grounding world model, this understanding. So, it's I don't think that there are barriers now. What the only barrier is time, because you're going to have people building these agents. As more and more of these agents are built out, as more and more of this spatial programming and this universal domain graph of the world, this digital twinning of everything with context baked in, as all of that is evolving and these agents are being built out and these agents are learning and growing in their knowledge and learning from each other, then, it's just going to continue to evolve, So really, to me, it's just time. But I don't think it's as much time as people might think, because the really cool thing is we've had all of these emerging technologies that have been growing siloed, right? But they've all been growing. And like we're at the point where, there's apps on your phone where you can scan a room and get a 3D model from it, right? Like there's all of these capabilities that the beautiful thing about the programming language of the spatial web protocol, this HSML, hyperspace modeling language, is it not only becomes a language that these AI can communicate across, but it also becomes the common language for all emerging technologies to be able to become interoperable. So, and I'll give you an example of what that looks like. NASA JPL, right? They're one of the beta partners for Versus, and they're using this technology for their Artemis project, and they may have one team, located somewhere like, say, here in the United States, and they're building the rover, and maybe they're using NVIDIA Omniverse to build it, right? And then there's another team over in Europe, and maybe they're using Unity to build some other aspect of this. They can all come together in this simulated digital twin environment, and it does not matter what technology they have built with. HSML bridges it all. And that's going to enable a level of collaboration that we've never seen before. It's never been possible to have that level of collaboration between teams, regardless of what technology each one is using or prefers or whatever. This digital twin environment with HSML bridging it all, it just creates this level of interoperability that brings it all together. So when you're talking about IoT and distributed ledger technologies and AR and VR and, AI is this powered intelligence that is, drawing all of these connections between it all. It's it's kind of mind blowing. That's why I feel like we're about to enter this phase of innovation like we've never seen before. The level of innovation that this is going to spark is going to be so fun to watch it unfold. And that's why I say all of this is an open source dream, because open source developers, they want to be able to have the tools and then just build with them, and to be able to have access to all emerging technologies and what you can do with them all together, and have them powered by these kinds of agents that are self-organizing, adaptable, can learn, plan, and act in real time with live data.
Do you think that it makes sense to build agents that can browse the web for you? It looks like it's the direction that everyone is taking now.
I think that's the direction everybody's taken now because that's what they've got. We're in the World Wide Web still. I think that it's going to look totally different once we are in this, once our internet is, enabled with this, digital representation of every physical thing, and it's all powered by AI. The way we search, for a lack of a better word, because that's not really what it's going to be for this next era. It's going to be kind of a knowing, right? And these AIs are going to be the ones that have the knowing, and we'll have several agents that we're working with throughout our day that are helping us with all kinds of various aspects of things. Maybe we'll have one main agent that's tapped into it all, and communicating with all these various agents. But, it's going to look very different. Just walking down the street is going to look very different, because when you have a digital representation of every physical thing, and then there's going to be devices that crop up to take advantage and help us navigate these experiences. It's going to be this augmented reality kind of experience that we've kind of known was possible and we've envisioned, but the framework wasn't there. This is going to be the framework. It's exciting. I know, and I know I get really excited about it.
It's exciting, but I'm curious, what are some of the unintended consequences? Like, aside the excitement, like what are the potential,
what could possibly go?
Good stuff that could
Right.
come out of it? Because it sounds exciting, but then I was just visualizing this future you were describing, and I'm like,
Well, what's really interesting, though, is that the Hyperspace transaction protocol, this new protocol layer that enables this whole digital twinning of everything, it's a super secure protocol. So, right now we're using all of these emerging technologies in a very unsecured environment. The World Wide Web security was an afterthought. And, that's why we're dealing with all these really hard challenges like hacking, tracking, faking, everything else, because it's centralized and it's not secure. When we have all transactions start taking place at every touch point, then permissions can be baked in, credentials. You might still have faking, right? But it's going to be really obvious that it is. So then it becomes parity, right? It doesn't become fraud, because when you don't know if it's real or not, then you can get tricked, right? But if there's this zero knowledge proof environment between all these nodes within the network, and it's all powered by AI, then there's going to be confirmations there without even having to give away sensitive information to third parties. There's a security layer in that. And you'll be able to, that puts the power back in the hands of the people too, as far as being able to decide what happens with their data, who accesses it. You can set expirations on access and things like that. And, right now, look at what has happened over this last year. All of the major data centers that hold all of our sensitive information have all been hacked. They've all been hacked here in the US, at least. Everybody gets tons of texts and calls and things that are all trying to defraud them and trick them, because they have all these points of data now, of all this sensitive data, that it's real easy for them to pretend that they are from some organization and give you a sense of security because they've got these sensitive knowledge points about you. It's really a problem. And this will help us move into a space that solves a lot of the vulnerabilities that we are currently living with. So I know you were asking what could go wrong, and I'm sure that there will be things that we will have to address and, challenges that will crop up. But from where I see it, we're going to have a lot of really positive outcomes that fix our current situation. Yeah, I mean, I don't know.
The part that I like is you run it locally and it's distributed. Like that's the part that I feel much safer about than having a massive centralized data center.
Yeah. Hmm. Yeah, I mean, if you're able to set expirations on access to your data for entities that don't need it but for a moment or something like that, um, how wonderful is that? If if we would have had that all along, we wouldn't have these issues with these giant data centers getting hacked and having all of our sensitive information in them. Um, yeah.
So many decentralized AI systems still rely on centralized compute. So I'm just like, what's the realistic roadmap for fully decentralized AI?
Yeah, well, I think that we're going to see it unfolding, this year. I mean, the interesting thing is, versus they built this next protocol layer, but they built it because nobody was, and it had to happen for what they envisioned with this next era of technology and what they wanted to do, right? So it's like, okay, we'll build it, and then they donated it to the public, donated the IP to the IEEE, so that all of the global standards could be developed around it, right? This global core standards, because it has to be a global standard. Everybody around the world has to be using the same protocol within the internet, or else it doesn't work. So it can't be private. It has to be open. It has to be public. And they knew that. So for the last 5 years or so, the Spatial Web Protocol has been in development with the IEEE, this global standard, but it was voted and approved last summer. So, you know, what Versus has done is they built their Genius platform, and that's really the first entry point for the public to be able to model these agents and build, within this expanded area of the internet and all this capabilities and everything else. And so yeah, they opened up their beta to the wider developer community last summer. So there's a lot of people who are already building in this space. So when it gets launched to the public, which should be late spring-ish, something like that. When they launch to the public, there will already be stuff modeled and in there. There will already be some filling out of this universal domain graph that then everybody will be able to build on the same way. Think of when the World Wide Web started, when HTTP and HTML enabled it to where I could build a website. I can have a web domain, and I can build a website and have people draw people to me. Before that, you could just send messages from computer to computer, right? Now I have a domain, I can attract people here and do whatever I want within my domain, establish some form of commerce or be a news site or be whatever. It literally gave the tools to the public to build what they envisioned in that space of capabilities. And that's what's going to happen here. So, just like we could build a website, anybody's going to be able to build a space with domains and agents that are empowering something within the space. Whether it's for complex systems like, a company, bringing together all of their various data and departments within their entire organization from, if it's like supply chain from raw materials all the way through to distribution. And these agents will be able to communicate with each other, monitor all aspects of the flow of that supply chain, and and they'll be aware of it at all times and be able to share information with each other at all times. This is going to empower operations in a way we've never seen before.
Yeah, makes a lot of sense. Yeah. Thank you so much, Denise, and Sofian. Super insightful conversation. And before we go, Denise, where can our listeners and community find you on your social platforms?
Sure, you can find me on LinkedIn, and I actually just launched a new platform, an educational platform for active inference AI and spatial web technologies. It's called Learning Lab Central. You can find it through my LinkedIn, but if you go to my blog deniseholt.us, you can find it there, or you can go to learninglab.immersionpublishing.com, and it's EMMER, immersion. So. Yeah.
Amazing. Thank you so much.
Thank you,
Cool, Denise,
Sweetie, and
amazing
thank you,
setup.
Sofiane.
Thank you for taking the time today.